Hi guys, I am Muchakwa Al-Mtangeni with Maths XYZ, and today we will be doing shapes and measurement, and the shape that we will be looking at is the cone and also the sphere. Alright, here we have a shape of a sphere which is upright and also the one which is looking down. So what we have here is the height which is in the middle of the cone, and also the radius here, and the shape of our that makes up the triangle, where the height, the radius, and also the slant height is the right angle triangle. So the height, the hypotenuse of this triangle, it's the slant height of the cone. So when we are calculating the surface area of a cone, as I've explained, that the surface area include all the shape, or I mean all the face in the shape. In this case, we'll be summing up the area of a circle and also the area of the big triangle that you can see there. So what we do is to add up the area of a circle, which is the bottom. So that will be the area of a circle plus the area of that shape here, which looks like this. So here the area of this shape here is equals to the circumference of the circle multiplied by the slant height. So in this case, we don't use the height, which is h here, we actually use the slant height, hs. And to find the value, or the value of the slant height, we have to use the theorem of Pythagoras, which states that the hypotenuse squared is equals to the opposite squared plus the adjacent squared. So in this case, the hs is actually the hypotenuse, of which hs will be hs squared, it will be equals to h squared plus r squared. So now here we will be trying to find the value of hs, which is the slant height. So to find out the circumference of a cone, of which it will be circumference of a cone is equals to the area of a circle, which is the base pi r squared, plus the circumference of a circle, which is 2 pi r multiplied by the slant height, which is hs. So what we have here is we have the circumference of the the surface area of the cone is pi r squared plus 2 pi RHS. So remember, in this case, we don't use the height, which is in the middle of a cone. We actually use the slant height, which is HS. And I've shown you guys here how to find the value of that HS. We have to use the theorem of Pythagoras, provided that we are given the height of the cone and also the radius of the cone. So that will give us the value of the slant height. Then moving on, when the sphere is open or when it's hollow, remember that when it's closed it's also called solid, and when it's open it's also called hollow. Then with that means that we won't have to include the area of a circle, because that's what closes it. So for example, in this case, if maybe this side it was open, let's say we didn't have this closure here, we actually let's just draw that it was supposed to be like this, but now that it will be open, that means that we have to exclude the area of the top circle. In this case, as you can see, that it's an upright cone, so that means that the surface area in this case, it will be only the area of this shape of the cone. So it looks like that's the shape that we have to find the area of which we know that with this shape, the area of that shape is equals to 2 pi r, of which the 2 pi r we know that is the circumference of a circle, and that multiplied by hs, which is the slant height. So we still have to use this very same equation. It's just that this case we exclude the area of a circle, which is pi r squared. Then having done that, we know that hs, to find the value of hs, we have to use the theorem of Pythagoras, of which hs squared will be equals to r squared plus the h squared. In this case, we know that r is also the radius of the circle in this case. So having done that, we know that when it's open, this is when it's open, or when it's hollow is the same thing. So when it's open, the area, or the surface area of cone is equals to 2 pi r hs, of which we know that hs is equals to the slant height. Then after having two circumference surface, after showing you the circumference surface area, I mean to say, of a closed cone and also of an open cone, we now have to calculate, have the equation for the volume of a cone. The volume of the cone there, it doesn't change whether it's open or it's closed, it remains the same. So the volume for both shape, whether they are open or whether it's closed, is equals to 1/3 multiplied by pi r squared h. Remember, pi r squared is the surface area, is the base area of the cone. So that means that it's the base area of this cone is a circle, which is pi r squared, and that's multiplied by h, which is the height of the cone. Remember the difference now, that when you are calculating the surface area, the height that you use is the slant height, but then when you are calculating the volume, the height that you use is actually the right height of the cone, which is in the middle of the circle. Now you can see the difference, that this one you have to calculate it, and then this one, most of the case, it's actually given unless otherwise stated. Alright guys, I hope you understood that we have when it's closed and when it's open, it does disturb the equation that we use. Alright, and then moving on to a sphere, of which I didn't really draw it nicely. In a sphere, it's like a soccer ball or a football that you use. So from the center of a ball to any point in the skin of a ball, it should be equidistant. That means that all the radius in the sphere, they are actually the same. So remember, when we are calculating the surface area, we have to include all the shapes of the face of that shape. So in this case, we have it looks like we have four faces in a ball, of which is the top and the bottom, and also the left and the right side. So that's why when we are calculating the surface area of a sphere, it's equals to 4 pi r squared. Remember, pi r squared is the standard equation of area of a circle, and then multiply by 4, that's where we have the surface area of a sphere. Then having done that, having the surface area of a sphere, the volume of a sphere, the standard equation for that is equals to 4/3 pi r squared h. Remember now the h, which is sorry guys, I made a mistake there, we don't have that. It's pi r squared cube. It's actually cube right there. So that's the volume of a sphere. And then when moving on to this, as you can see that this shape here is actually different from that shape then. So this one is just it's called a hemisphere, which is half the sphere right here. So with a hemisphere, it can be open or it can be either closed. So that's why when we're calculating the surface area of a hemisphere, so I'll just write hemisphere right there. So the surface area of a hemisphere when closed or when it's solid, it's equals to the area of a sphere, which was 4 pi r squared divided by 2, because this case is a half of a sphere. And when it's closed, remember that we'll have another circle which closes it. So we have to now add the area of a circle, which is equals to pi r squared. That's when we need the surface area of a closed hemisphere, the equation is equals to 3 pi r squared. Sorry guys, it's 3 pi r squared. And then after having that, what we do now is we have to also have an equation of a surface area of a sphere when hemisphere, I mean to say, when it's open. And the equation for that is just the 4 pi r squared of a sphere, full sphere, divided by 2. This case, we don't have to include the area of a top circle since we don't have that because it's open. Then here we're gonna have 2 pi r squared. Sorry guys, 2 pi r squared. Then when it comes to volume, when it comes to the volume of a sphere, it's actually the same whether it's open or whether it's closed. So if it's open, I'll just write that, and when it's closed, the volume of a hemisphere, it's actually the same. So what we have here is equals to the volume of a sphere, which is this one, volume of sphere, which is the one that we have already done, divide by 2. We have to divide that by 2. So that will be 4/3. So I'll just multiply by 1/2 to show that we are actually having it in half. So that will be 4/3 pi r cube. This is the volume of a sphere. Then multiply by half, that means that we need it in half. And then here we're going to have 2 multiplied by that. This will actually be 2. So that will be 2/3 pi r squared. I mean, no, it's a cube. Remember why we're having a cube? That's because that we need the SI unit of a volume to be in cubic and the SI unit of an area in squared. Then let's just do a quick recap. When it comes to the surface area of a sphere, the surface area of a sphere is when we sum up the top and the bottom face of a ball, and also the right and also the left side of the ball. That's why we have to multiply the area of a circle, which is pi r squared, by 4. And the volume of a sphere is equals to 4/3 pi r cube. And then when it comes to a hemisphere, we have 2 types, of which it can be open or it can be closed. So when it's closed, we also have to include the area of a circle that closes it. That means that after having dividing the hemisphere by 2 to show that a hemisphere is half the sphere, that's when we divide by 2. And then we now have to add the area of a circle which closes it. That's why we end up having a hemisphere closed surface area as 3 pi r squared. And then when it's open, that means that we won't be having any circle that closes it. Then that's where it's just the sphere divided by 2. It's pi r squared divided by 2, which will still be 2 pi r squared. And moving on to a volume, whether it's open or it's closed, the surface area, the volume of a sphere or a hemisphere, I mean to say, is the same as the volume of a sphere divided by 2, to show that a hemisphere is half of everything that a sphere is. Then here we have 4/3 as the volume of a sphere, pi r cube. This is actually a cube. And then multiply by 1/2 to show that it's a half, and our answer will be 2/3 pi r cube. Remember, the SI unit of a volume is always in cubic, and the SI unit of area is always in squared. Then let's just do also a quick recap on the cone. A cone, it can be either open or it can be closed as well. So when it's open, we know that the surface area is always the sum of the area of the face in that particular shape. So in this case, it will be area of this circle and also the area of this shape right here, and that will give us pi r squared as the area of the circle, and the area of this shape, it will be the circumference of the circle multiplied by the height, of which in this case the height is actually the slant height. And I've shown you guys how to get the value of the slant height, which is h squared equals to h squared plus r squared. Because it's a right angle triangle, we are now allowed to use the theorem of Pythagoras. Then when it's open, we only include the area of this shape right here, of which the area of that is equals to the circumference of the circle multiplied by the slant height. The slant height, we found it the same way we found it here, which is by using the theorem of Pythagoras. And the volume of whether it's open or it's closed is still the same. It's equals to, this is actually 3, guys, sorry, it's 1/3. The volume of open or a closed shape is the same, which is 1/3 pi r squared h, and the h that we use in this case is this h here, which is in the center of the cone. I hope you guys understand this lesson, and to understand even more, please tune in for our next video, because we will be doing an example of which it will be including both the sphere and the cone in one example. That will just give you an idea, because most of the question that arises from shapes and measurement, when they are asking about a cone, they also include the sphere in the very same question. Alright guys, I hope you understood this lesson and enjoyed, and also if you didn't, please just let us know, and then we'll get back to you. Also subscribe if you haven't to YouTube channel Maths XYZ, so that you'll be able to get notification when we upload videos. Thank you.